All right, so next up, division of decimal fractions, or decimals in general. So in order to do division of decimals, we need to know what division means, and we have a couple of definitions of division. So one definition of division was repeated subtraction. Another definition of division was that sharing, or the partition method of division, which I called groups in. So for a problem like, how about, let's take 75 hundredths and divide that by 15 hundredths. So as far as the groups in, this says how many groups of 15 hundredths are in 75 hundredths. And so we can draw that out. So I'm going to attempt to do that. And I'm guessing here, I don't know if I guessed right, that does not look right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that one was right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got a little carried away that way. So here's my 10 by 10 grid. So if you don't have if you don't have graph paper, again, you might want to get a ruler for some of this, or get some graph paper. And so then I'm going to split this into tenths. So I think it's probably safer to use my line tool here. Oops. I guess with graph paper, this might be a little overkill. All right, so there are 7 tenths. From that, let's shade them. 1, 2, 3, 4, 5, 6, 7. And then I have 1, 2, 3, 4, 5 hundredths to put in there too. So this is my 75 hundredths to start with. And then in there, I want to look for groups of 15 tenths. Sorry. I think I'm going to do this in a sequence. Copy that. So 15, so that's 1/10 and 5 hundredths. So like here is one group right there. And then maybe I'll switch to a different color. There's a 10th here and 5 hundredths there. So there's a second one, and then I can keep looking for these. So here's a 10th and 5 hundredths there. So that's my third one. And then, oops, I have to switch colors there. Kind of separate them. I want to switch colors. There we go. So 5 hundredths and a 10th. So there is a fourth one, and then I can see the fifth one hiding on the end. And so there is my fifth one. So it looks like I can say, all right, to answer this, there are 5 groups, 15 hundredths in 75 hundredths, period. So I can restate it as a division. 75 hundredths, and remember, we're trying not to read slang, that's not 0.75. divided by 1500ths is simply just 5. Now, if I go back to this question that I asked here, how many groups of 1500ths are in 7500ths? Well, that could be written in the goes into symbol form. So 1500ths goes into 7500ths, right? And when I was doing this, I was looking for hundredths, right? Looking for hundredths as individual objects. Right, so I found 1500ths there, and then I found another 1500ths there, right? I was counting 10 and 5 is 15. So this problem is equivalent to, so this one right here means the same as, how many times does 15 go into 75? Right, and I can just count up 15s to make that happen. Well, 2 15s is 30, and another one's 45, and another is 60, and then 75. Oh, that's 5 of them. There are 5 groups of 15 in 75. This is just whole number division. And we're good at whole number division. Maybe not great, but we're good at it. If I can rewrite a decimal division as a whole number division, then it's no problem. And that's the key to division. Now, modeling addition, modeling subtraction, modeling multiplication, as long as you choose the right numbers, it goes pretty well. Division, when you're modeling it like this, you have to be a lot more careful about the choices that you make in terms of the numbers that you're dividing to draw your pictures, because otherwise the pictures get just too hard to draw and contemplate. So anytime with multiplication, division, multiplication, addition, and subtraction, I can kind of make up almost any problem I want off the top of my head, and I can draw the picture. But I can't do that with division. I got to think about it carefully, because the number choices do matter in terms of drawing the picture, just because division is really the harder of the 4 operations. But the key is that we're looking for groups in, which is like long division. So I'll draw one more picture of these, but I'm not going to draw as many as I did for the other operations, just because there aren't as many opportunities. But I am going to do one more. Let's try, how about, um, 0.9 divided by, I did slang, 9/10 divided by 3/10. So the way I want to think about that is again, the question, groups in, we could do repeated subtraction. So how many times can we subtract 3/10 from 9/10? So we'll demonstrate that in a second. And it turns out that's kind of an equivalent question to how many groups of 3/10 are in 9/10. So in terms of the subtraction, we can do that up here. We've got 0.9 9/10 minus 3/10. And we know already how to subtract, that we just have to line up the decimal points. So 9/10 minus 3/10 is 6/10. And then we just keep repeating that. 6/10 minus 3/10 is 3/10. And I keep doing it till I can't anymore with whole number, or with positive numbers. 0.3, 3/10, excuse me, minus 3/10 is 0. And so I could see I was able to do it 3 times. Similarly with the picture, how many groups of 3/10 are in 9/10? right? We can think about it this way, and we could draw out our 3/10. So there's 1, 2, 3/10. And I want to know how many of those live inside of 9/10, so that I can draw my 9/10. So 1, 2, 3, 4, 5, 6, 7, 8. Is that 9 right there, I think? Find out. 1, 2, 3. Oops. Oh, one more try. Wish me luck. There we go. Oh, well, we're going with a crooked 10th. 1, 2, 3, 4, 5, 6, 7. Yeah, I was right. 8 and 9. Excuse my messiness today. And so then over here, I can say, well, here's 1. Oops. Here's 1. Oh, come on. I'm having button pushing trouble today. There we go. There's 1 group right there. There's another group right here. And then here's another one right there. So I can find 3 groups of 3/10 and 9/10. And when we do that, just a reminder, we really are thinking about these whole tenths. Now, before I was thinking about hundredths, this time I'm thinking about tenths. And basically, I have 3 things there. I have 9 things there. How many groups of 3 are in 9? There are 3, right? Bottom line is decimal division boils down to whole number division. So this is like whole number division. Exclamation point. But there's a catch. The catch is you've got to get a whole number. And the double catch there, it's the divisor has to be the whole number. So if the divisor is a whole number. And the question is, well, why is that? Exclamation point. Well, when we're looking for groups, right, when we see a group, we're counting stuff, right? I see 1, 2, 3 things there, right? And I was looking for groups of 3 over here. If I go back here and think about what happened here again, when I was looking for groups of stuff here, I was looking for groups of 15 at a time, right? Here was a group of 15 right there, a long and 5 ones in this section right there. Sorry, that's getting so messy. The highlighter will help. Right? A long and 5 hundredths, 5 units. I was looking for a whole number of things. So that's it right there. As far as division goes, it's just like whole number division as long as the divisor is a whole number, because it's the divisor that we're counting. We're looking for this kind of a group there. So then I can move away from the toys and say, all right, let's try that with some other problems and then test it out. So for example, if I want to do 2 and 4/10 divided by, let's say, 5/10, all that really matters about these when I go to do the division is that I have a whole number group of things. Now I can't just change the 5 alone, because here I'm comparing tenths to tenths, but I can easily switch the tenths, because this is really 2.4 over 0.5. I can multiply top and bottom by 10, division is a fraction, and say, hey, this is the same thing as 24 divided by 5. So it kind of also comes from the ideas of fractions. So this is the same problem as 5 goes into 24. So let's do it and test it, see if it really does truly work. So let's see, 5 doesn't go into 2, but 5 does go into 24. 4 times 5 is 20. Subtract, and I get a 4. Now, we were playing before, there's really that decimal point moved from here over to there. And 24 is the same as 24 and 0/10, so I can keep going here. So 5 goes into 40 here. How many times? Let's see, 8 times. 8 times 5 is 40. And I finally get a 0 remainder, and I'm done. The catch is the decimal point matters. It now goes there. So I think 2.4 divided by 0.5 is 4.8. And to check that, I'm going to use a slightly different model for division. I don't know if you remember the missing factor model. Which relates to our fact families, which basically states this in reverse. What times 5/10 is equal to 2 4/10? Now we think the answer is 4.8, and we know how to multiply, so we can check it to make sure this algorithm does work by saying, okay, well, what is 4.8? 4 8/10 times 0 5/10, or just 5/10. And we have our algorithm for that. We just ignore the decimals. 5 times 8 is 40. 5 times 4 is 20, plus 4 is 24. No point multiplying by 0. There are 2 fractional places in the factors, so there must be 2 in the answer. So 4.8, 4 8/10 times 5/10 is 2 4/10. So it does check out. So again, the division algorithm for decimals is to make sure that the divisor is a whole number, and then we kind of proceed like normal. So there's a couple more steps. Let's fill them in. So the first step in the division algorithm, and again, this isn't drawing pictures, it's just a series of steps to get it done, is that we have to make the divisor a whole number. Second thing is we have to adjust the numerator, the dividend in the same way. So once we do that, it's like whole number division. Now there is a third part though. This adjustment of the dividend tells us where the decimal goes in the answer. The answer is called the quotient. And then otherwise we just divide like whole numbers. So it is a bit complicated, sequence of steps to follow. It's a little, actually even a little harder than maybe fraction division, I think. But the key is we can easily divide with whole numbers. It's much harder to divide thinking about fractions. We have to adjust the numerator just like we adjust the denominator, divisor versus dividend. And that adjustment tells us where the decimal goes in the answer. Otherwise, it's just like working with whole numbers. So let's do one more example, and then we're out of time for fun with math today, and almost on schedule. So let's take, how about, $498 thousandths divided by 6/10. So we're going to try to do this without a calculator. In that case, we want to rewrite it as 6/10 goes into 498 thousandths, right? Tenths, hundredths, thousandths. The key is the divisor has to be a whole number, so that decimal needs to be moved once. So then that decimal needs to be moved once, which tells me where the decimal goes in the quotient. Now, oftentimes when I have too much of a mess like this, I like to then rewrite it again. So I'm going to write it as 6 goes into 4.98. Okay, welcome back, Lauren. Sorry to hear about your computer. I hope it's okay. So again, I decide on the adjustment in the denominator, the divisor. That forces me to adjust the dividend, the numerator. That tells me where to put the decimal. Oftentimes it's worth rewriting so we have a cleaner space to work with, and then we just move along, see what happens. So 6 goes into 4 0 times, and I like the leading 0. I just remind myself where the decimal is going to go, and then next I move on. 6 goes into 49. So I think that would be 8 times, because 8 times 6 is 48. Subtract, I get a 1, bring down the 8. 6 goes into 18, ooh, lucky day, 3 times. And 3 times 6 is 18, and I get a 0 remainder. So the answer here should be 83 hundredths. Drawing this would be a mess. I don't want to go and do that. It would be hard to do with the toys that we have, if not impossible. But we do have an algorithm now to come up with an answer. Again, we also have access to calculators to check this, and we can use multiplication to check this. Just kind of a quick check off the top. If I were to multiply these together, the result should have 3 places, because there's 1, 2, 3 decimal fractions there, 1, 2, 3 decimal fraction places there too. All right, so we're just about out of time for fun with math. Let's take a look at where we are in the scheme of the course. For homework, you've got this multiplication activity, which is like we were working on in class today, and you could either use the real toys if you have access, take pictures of them. You could draw it on paper, in which case I'd expect a picture like this with some explanation and either one of the versions of the expanded algorithm, let's call this one the expanded algorithm, or I have the regular expanded algorithm over here and then the standard algorithm. So I want a little bit of that. If there's any trading that has to happen, you should mention that like we did in some previous examples, and then you just need to demonstrate those problems, and you'll have either a hand-drawn picture, an app picture, or a picture of the real toys along with some explanation and some algorithm. Otherwise, I think most of you finished the regular homework. If not, you can apply a late pass or just ask me to do that for you. So that would be homework 6.2, decimal operations. The reading accidentally got signed early, so thank you all for finishing that early. Section 6.3 is about ratio, percents, proportions, and scientific notation. And so here I have just a regular homework assignment on ratio and percent, and then an activity. So we'll get to this next class. So I was hoping to start this today. And this one is kind of similar to what we've been doing. We're going to draw percentages. Percentages can be decimals, percents, or fractions. And all of them can be represented as a part of 100. So we'll get some practice drawing percentages here. There's some homework questions on that, and there's some examples in the book. When we were playing around with multiples and fractions, we used color rods. So I'm kind of using, these aren't really color rods here, but I'm using colored rectangles to try and show parts of a whole. And the contrast isn't very good in this picture here. Let me zoom in on it. I'm gonna move this image. Let's see. Yeah, there's little tiny dividing marks in here and they aren't very visible. I'm gonna have to fix that image. They're more visible with the green than the purple. All right, I'll have to go back and fix that image. So I'll rebuild that image. But if you're bored over the weekend, take a look at section 6.3, take a look at these examples. We'll do stuff like this in class. So I just wanna teach you how we can use graphics to solve a problem involving percent increase and percent decrease. And so that's what we'll be doing in the next class. So as far as our schedule goes, because of the snow sick day the other day, we are now officially a day behind the schedule, and I will adjust due dates as necessary. So we'll likely push next week's exam off to the week after. So without the snow sick day, I intended to do section 6.2 Monday, 6.3 today, and 6.4 Monday, but we're behind. Unfortunately, we have our catch-up review day over here that might help. All right, thank you for playing today. Let me get my real face here. There we go. If you have any questions about the other assignments, be sure to get in touch with me. Otherwise, take care and do good math and other good stuff. Adios. Bye.